Thanks for coming to our talk about addressable like game content management. We can start with some intros. My name is Attilio. I'm a technical lead at Unity. I'm part of this Unity Studio Productions team. We are a team of experts working on external projects, doing all kind of things like porting, game optimization, backend, current infrastructure, live ops, and everything in between. We basically help teams make the most out of Unity and their games. And here's Moritz.
Hi all, I'm Moritz Wundke. I'm one of the principal client engineers for Scopely working on StumbleGuys. So we hope you enjoy the session.
So we're going to start by sharing some general information on how to use Addressable to optimize your asset management, effectively work with Asset Bundle, and then Moritz will share how they do that in StumbleGuys. We have a pretty packed agenda, so let's get started. So in this session, we're going to assume that you're familiar with the Asset Bundle system, with the Addressable system. So we won't cover the basics, but we will rather look into more advanced topics. We will then have a Q&A at the end. If you run out of time, just grab us outside. Good. So advanced content management techniques. In this section, we're going to share a few tips into how to effectively group your game assets into bundles, pitfalls to look out for, and how to improve performance. Good. So when defining your bundles, you want to group your assets based by how often they use together, rather than by type. Forming groups is a bit of a similar process to packing sprite sheets, if you ever went through that. So you want to group assets based by how often they use together to minimize the amount of bundles that are loaded in memory at the same time. We often see in projects having like a materials group, UI group, prefabs group, and so on. This is not ideal for reasons that I will cover later. Rather, you should have an intro group, main menu group, level 1, and so on. So you basically want to follow the way players organically grow to your game to also minimize the amount of assets that are loaded in memory. You should prioritize isolating assets that will get players to the main menu and to the game as soon as possible, and everything else can be loaded later. So as I mentioned, you have an intro group, everything that is needed goes in there, one or more intro groups, of course, and then everything else you can load later. So players don't have to stare at a blank screen, and then you improve the game retention as well. When in doubt, you should prefer smaller bundles. The footprint of having smaller bundles today is reduced compared to older version of Unity, as I will cover later. So when in doubt, it's always better to avoid larger bundles. You can use the related profiler module to understand what's happening in your game. So you will see a chain where an asset is loaded, it has its dependencies, they get loaded as well. And then it helps you understand where to improve and optimize your game. If you're in an older version, you should use the addressable event viewer if you're an older version of Unity or of the package. And just one note on addressable scenes. So addressable scenes will always end up in their own bundles. So even if you pack them together with other type of assets in the same group, they will end up in something called streaming scene asset bundle. So something to look out for. It's normally better to put them in their own group because it's easier to understand what's going on. Managing dependencies. So when you load a bundle, when you want to load an asset contained within a bundle, Unity will also need to load all the dependencies of that bundle. This is why you often see games with very long boot time. If you run into the profiler, you will see a very long chain of downloads. One thing that we often see, as I mentioned before, imagine the game wants to load the main menu or like the intro screen, but that is part of a UI group because all the UI elements, the visual element dialogues, they're all put together in this group. What's going to happen then is that because of all the direct references that this group has, it needs to load all those screens, even though they are not needed yet. And because all those screens have all the other dependencies, imagine you have a post screen, end game screen, result screen. They all have their own dependencies. And you end up with this very long chain of downloads or loads if they're logo that will really take a toll on your boot time. It's very easy to end up with these unclear dependencies where a single asset will cause hundreds of download. Another example, another thing that we often see in projects, so imagine you have the final boss. So this final boss uses a cool shader. It's all nicely packed. You have the model, the animation, the shader, material in its own bundle, the final boss bundle. So players go through the game, they get to the end, this bundle gets loaded. So everything is fine. Now imagine the content team is authoring a new enemy. And when they create this enemy, they think, OK, this shader looks pretty cool. Why not reusing it? And this enemy is also going to be used from level 1, so very early in the game. Without really noticing what's going on, you're creating a dependency from the start of the game to the final boss bundle. So that means that the players start the game, they have to load and gain content. And then this final boss bundle may have its own dependencies and gain content, so you are basically making the dependency chain much longer. The solution in this case is to move the shader into its own bundle, and in this case, you break the dependency chain. So in Unity, you can right-click on any asset, you go to the project tab, and you do select dependencies. There's an example here. This was a scene. So you will see Unity will show its dependencies in a list, and it will also apply a filter in the project tab. So you will see actually what those dependencies are, and then you can understand how to minimize them or to reduce them. There's no hard rule for that because a lot of this really depends on your game. Like it's really specific on how players go through the game. So we can't just give a rule. That's how you do it. You really have to know your game well, understand how players go through that, and then reduce these dependencies. One thing that really helps in this case are asset references. Asset references are essentially soft references. It's basically the, in normal Unity, you have the inspector, you drag things, and there are direct dependencies. Asset reference allow you to control like when the asset is loaded, when it's unloaded, and they break these direct dependencies. So they won't need to load that dependency straight away. You have control in scripting over when it's loaded and unloaded. It's obviously a bit more work because you need to do that in code. You have to be careful. You have to release the asset. You might have memory leaks, but it's worth it. It really changes how your game is. Like the performance of your game will definitely improve. Good. So whenever asset bundle directly reference an asset that is not an asset bundle, an addressable asset, in this case, you have two prefab that reference a material, which is not an addressable, you will end up with a duplication. Imagine these two prefabs are part of different groups, different bundles. They will each bring a copy of this material because it's not an addressable. This leads to increased build size. The bundles will be larger because they have this duplicate material, and also memory usage, again, because of the duplication. And it will also bring potential bugs, as I will cover shortly. You can use the build layout report to help investigating and troubleshoot these issues. My recommendation is when you move to addressables, you should make sure to move basically everything you can to the addressable system. Like an hybrid approach where you move some of them to addressable has a lot of pitfalls. So that would be my recommendation. Similar case, you have an addressable scene, and this non-addressable scene uses addressable assets. Those assets will need to be copied in memory in the game build, again resulting in increased size on disk because the game build now is larger and runtime memory usage. It's particularly risky, we often see in projects when dealing with centralized data repositories because you're assuming there's one copy of that in the game, you change it, you edit it, but actually this change doesn't reflect, and it's because there's two in memory now. So in this case, as I mentioned before, when you start using addressables, you should make sure to use as much as possible addressables, especially with scenes. Make every scene an addressable, and have a bootstrap scene, which only responsibility is to load your first addressable scene, and then use addressable whenever you can. Make sure that this scene is as empty as possible. Just put a script. Don't put any text, because fonts are normally pretty large. And again, you're going to duplicate them in memory. So we often see in project 200 megabytes going over duplicates fonts. Good. So loading and unloading assets. So whenever you attempt to load an asset within a bundle, Unity also needs to load the corresponding bundle in memory, and then it loads the asset. It's possible to load specific assets. Imagine you have a group containing 10 textures. You can load one, the second one, and so on, but you can't unload them individually. So as soon as they're loaded, they stay in memory until the whole group is no longer needed, and it can be removed from memory. As a result, as I mentioned, if your bundle structure is not ideal, you'll often see increased runtime memory usage as the game goes on, leading to deteriorating performance and potential out-of-memory crashes. Imagine all your environments are contained in the same bundle. So you play the first level, you load the relevant environment 1 prefabs, you finish the level, you move to level 2, you load the level 2 prefabs, all the environments, but because they're part of the same bundle, the level 1 prefabs are still in memory. You keep going, level 3, level 4, runtime memory usage increases, and potentially then you can runtime memory, you run out of memory and the game crashes. Yeah, for this reason, as I mentioned before, group assets based on their usage, not on the type. Avoid large bundles with a large amount of assets. That will turn into a bottleneck for your game. And then, yeah, your game will improve based on that. Good. So internal asset bundle data. So as I mentioned before, when you want to load an asset, Unity first needs to load the asset bundle in memory. So the asset bundle contains, apart from the assets, a bunch of extra information and headers that will tell Unity what's contained in there, how to load it, how to construct the objects. So let's go through them. So there's the table of content is the first one. It's basically just telling Unity what's contained inside the bundle. And it's basically what allows you, when you load the asset by path or by name, it's basically what allows you to do that. Its size in memory is normally not a concern unless you have exceptionally large bundles with a lot of assets in there. You then have the preload table. So this lists the dependencies of each asset contained within a bundle, and it's used by Unity to construct the asset. Again, the size in memory for this one as well is normally not a concern, unless you have very long dependency chains, implicit and explicit to other asset bundle, then it might become something that you need to look at. And then we have the type tree, which so the type tree defines the serialized layout of the object contained within the bundle, which is basically a way to say it tells Unity what the types are, so Unity understands them and it can deserialize them. One important thing about type trees, so they're necessary to maintain compatibility when you update the Unity version, so the Unity engine version. So imagine you're working on a game, you build the game build, you build the asset bundles, and then you upgrade Unity. You make a new game build, but the asset bundle, which are in a CDN, so remote asset bundle, they're not being updated. If Unity detects a mismatch in the format of these assets, so basically like if the asset change is format between the two Unity versions, Unity can use the type trees to do something called safe binary read. So the binary read basically means that it's going to look at this type tree and try to construct this object regardless, even though the format changed. There is a performance cost to that. Safe binary reads are slower than stream binary read, which is the normal path. For this reason, you should try and, whenever you update the Unity engine, if possible, update all the bundles, and then you won't incur this runtime runtime performance cost. Good. So as I mentioned, because it describes the types inside the bundle, its type depends on how many types are contained within the bundle. So because each bundle has its own type tree, if you have bundles with a lot of different types, this one will grow larger. So the total size on disk will increase. On the other hand, the runtime memory usage won't increase because type trees are included in a global cache. So if you have a lot of asset bundles that contain the same types, they will keep more space on disk, but then on memory will be the same because the type is already loaded, it doesn't need to load it twice. It won't be duplicated. So type tree can now optionally be disabled. You can use this flag when you build your asset bundle to strip them. It will make your bundle slightly smaller and the runtime memory usage as well, because it doesn't need to keep this information. The downside is that it won't be able to do the safe binary read as I mentioned before. So if you update your Unity engine, and then there is a mismatch, and you want to load an asset bundle with a mismatch, Unity can't, so it will just, it won't allow you to load it. This is especially painful if you rely on bundles created by other users or by external companies. Imagine like user-generated content. You won't be able to load them anymore. So, and obviously you can't go to all the players and ask, sorry, can you rebuild this bundle with this new version because I updated Unity? Probably that's not gonna fly. So in this case, my recommendation is that normally it's better to keep type trees on unless you have a very strong reason to do so. One case where it's safe, normally safe to strip type trees, is for local bundles. Because the bundles are included as part of the build, whenever you update Unity engine, you make a new game build, you need to rebuild all the bundles anyway. So this retrocompatibility aspect is not as relevant. Loading cache. So this is a shared pool of pages where Unity stored access data from your bundles. This is global, so it's shared between all the asset bundle in your game. So it's important to mention, this has been introduced in Unity 2021.3 and then backported to 19.4. It's important to mention because previously Unity relied on separate caches for each asset bundle, which were called serialized file buffers. So if you had a lot of small bundles, you incurred an higher runtime memory usage because each bundle has its own serialized file buffer. This is no longer the case. So a lot of developers are aware of this behavior, so they avoid a lot of small asset bundles. This is no longer the case because now it's global. So as I mentioned at the start of the talk, the footprint of a lot of small asset bundle is not as relevant anymore. It's not as big anymore. So by default, this is set to 1 megabyte, but you can change it by scripting, doing asset bundle.memory budget kilobyte. The default cache size should be enough for most games. There are some cases where, for example, if you have bundles with very, very large objects, a lot of very small objects, in that case, it might be that if you increase that, you might have more cache hits. So it's something that you can try. It's on a case by case, so you can try and see if it leads to improved performance, but it's a bit of over optimization. So in most cases, that would be enough. CRC checks. So when bundles are loaded, you have the option to run CRCs, which stands for cyclist redundancy checks, to ensure that the content delivered to your game is exactly what you expect. They're basically used to do checksum validation of your asset bundle. So this checksum validation is calculated based on the uncompressed content of your bundle. So that doesn't include all the headers that I mentioned before, and it doesn't include the compression type because that's based on uncompressed assets. While this is convenient, it can have a significant impact on performance, especially on mobile and console. So especially if CRC checks are repeated for each asset bundle load. As you see, there are 3 options. You can disable them. So each group has its own setting. You can disable them, enable them for cached, enable excluding cached. So some recommendation in this case. So on console, asset bundle are normally included as part of the game installation on local storage that are loaded as DLCs. So in most cases, CRC checks will be unnecessary. And because of the performance cost on consoles, it's best to keep them disabled. On WebGL, all bundles are remote. Caching is disabled because it uses its own built-in download cache. So in this case, CRC should be left on. On all the other platforms, such as PC or mobile, it's important to do CRC checks for bundles downloaded from a CDN, so remote bundles. The reason for that is that you don't want the game to crash because the download was interrupted, or you want to ensure that the bundle is not corrupted, is not truncated, and also you want to avoid potential tampering if something happens while you request the bundle and something that comes back is not what you expect. So you should leave CRC on for non-cached bundle, and then as soon as they're in game and they're cached, you don't need to run them anymore. So in this case, you will leave the enabled excluding cached. In most cases, that would be the optimal approach. Good. So that was a lot about memory management, content management. Let's quickly go to some content loading techniques. So when you create the addressable content for your game, you have the profiles, you have the group, and you can define build and load paths. So that tells Unity where to build the assets, bundles, and then when to load them from. So within those, you can use profile variables to have more interesting setups and have parameters within those. Some of those are built in. You're probably all familiar with the build target, which is needed because asset bundles are not inherently cross-platform. So each platform needs its own set of asset bundles. Note this is in brackets. You can also add your own. As an example here, the URL is also a parameter. So there's two types. Brackets, which I just shown, is the build target. See, these are resolved at build time, and the resulting values are written in the catalog, so you can't change them anymore after the game is built. And then there's braces, which I shown before for the URL. These are resolved at runtime before the addressable is initialized. So you can use static field and properties for both types. You have to use, of course, the fully qualified names. So the cool thing, especially with braces, they give you a lot of added flexibility when loading game content, because you don't require to create a new build, you don't require users to download an update, you can just parameterize, and then basically change the way your game acts based on these parameters. You basically set them before. You have to make sure that those are set before you load the first asset or before you initialize the addressable system, because they only evaluate it once. So they evaluate it using reflection, you set all the relevant values, and then you start, and then the addressable system will use those. So if you make any changes later on, it won't detect them. So for example, as I've shown before, here the URL is a parameter. So I can do redirects. If I'm on development, I can point to some local storage, some like local web storage. If I am on production, it can go to somewhere else, and so on. So that's an example where this is a dynamic one, so it's in braces, and then the build target is in brackets. So when developing live game, for example, it's common to have a single build that you use for different environments, like development, staging, production, and so on. One cool thing that you can do is that for each different environment, you can load different content. For example, you want to load some content only on the development build, but on the staging one or the production one. Then you can add embraces the environment as part of the load path, and then you can do redirects based on that. A similar approach you can use for other settings, or for example, if you have live seasons, you can load different texture, different assets based on the active live season. So again, you put that in braces, you have your live season with a fully qualified name, and as soon as you change it, it would just load a different bundle showing different backgrounds, a different main menu, and so on, without having to make any change to the game build itself. Keep in mind that these you need to make sure Unity doesn't strip these variables, because they are evaluated using reflection, so you need to make sure they are referenced somewhere, so Unity doesn't strip them. And then we have the transform internal ID. So this is similar, but in my opinion, more powerful. So this is an optional function that is used to introduce additional logic where Unity evaluates resource locations. So every time Unity wants to load an asset or a resource, it will run through that. It's especially useful for remote fetching when you want to transform the URL, doing redirects, adding parameters such as secret keys, and so on. You can also use it for loading specific version of your asset. For example, imagine you have a mobile game. You can check the capabilities of your device or the size of the screen, the density, and so on. And it's like, okay, this is a low resolution screen. I can load low resolution textures. This is a high resolution screen. It's a tablet. I can load high resolution texture just by running through this function. You need to make sure, I'm going to show an example. You need to make sure to register the callback before you load any asset, because otherwise you will miss some of these resource location resolutions. As an example, we have the secret key. I want to append the secret key to my CDN calls. So I have an edit function that I'm going to call when the game starts, before I start loading stuff. And the only thing I do is I'm assigning this internal ID and transform function to my own secret key function. And then internally, what this function does, it gets a resource location. So this is not just for asset bundle, it's for every resource that Unity is loading. So I'm basically first going to check, is the resource type of type asset bundle? Like, am I loading an asset bundle? And is the internal ID, which in this case is the URL, does it start with HTTPS? Yes. it means that I'm downloading an asset bundle. Then I'm transforming the internal ID, I'm appending the key, secret key, and so on. And then it keeps going and goes back to the normal loading logic. Otherwise, if it's not any of that, I just return the internal ID and transform, and Unity just keeps doing its thing. I guess this is optional, so yeah. In my opinion, this is pretty powerful. You can have very interesting logic with that. Good. So that was a lot. I hope you found that interesting, and I'll pass it over to Moritz.
Oh, yeah, thank you.
Thank you.
So first of all, I wanted to go a bit into the numbers of the game so you see the huge scale that we are dealing like day-to-day basis. We have about 4,500 cosmetics there in the game, skins, whatever you like. There are cosmetics like built every day, plus 123, I don't know, should be more right now. Levels, okay, it's clicking, right? Okay. Click, 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 click. I just keep, okay. So managing scale and content is vital to the game. On top of that, we have a few challenges, like Stumble Guys, if you play it, we operate on short releases. We deploy on about 9 platforms. We have about 200 artists, visual effect artists, like a lot of content folk creating stuff on a daily basis. And sure, we have to ensure that that content works. Like the first level has to work. The first ever cosmetic that we did like years ago, it has to still work. So breaking the bond between what is content and what is release is like the key to get this rolling. So we chose Addressables. We thought it was like the best battle-tested framework that we could build upon. It's also flexible enough. It is production ready. For example, you can adapt it whatever you want. Basically, we forked it, so if you have to do your changes, you do it. That's like super good. And then let's go into what we do with the content, actually, content authoring. So just a bit of context of how the game is developed. Stumble Guys is built on what we call a release chain. I don't know if you know what that is. The idea is that every release that we have is sourced on the previous release. So this is basically for stability. For example, if we have a bug fix on an older version, we put this in that older release and it gets out to merge the release chain up. So this is to avoid regressional bugs, which is cool for stability, but it is the worst thing that you can think of for content, because if you have to update your content and you do your content, you add a new skin in your older release, but it has to be different from a newer release, you will go into like a merge hell that nobody will escape. So we thought, okay, if that's the idea, we just split the project. We have our Stumble Guys project and we have our content project. Now, our content is separated. It's an independent package. We even can enable trunk development, so our artists don't like our release flow, which is like normally they're artists. They prefer doing one feature, moving back to main and again. And we inject that package automatically when we run the editor. We have an initialize on load function. What we do is if the package is there, we just pull it from Git, and if it's not there, we just clone it, and then we refresh Addressables, and everything is there. So the idea is basically you get your content and you put it in every release that you're operating. That would also be the only way to update a release that is live. Like we cannot change the code of that because it would be too dangerous. And this is basically the idea behind. To trick Unity a bit, we have a stub package. It's basically that's the package JSON, the meta file, and nothing else. And then we clone it into there. It works pretty well. It seems like, should it work? Not? Yeah. It's like magic, and it works. There could be better ways if there are like more ways to do it, but we used Git. If you do like with Perforce or you use SVN or whatever, it should work equally good. So then we end up with this. This is basically on the left side. What you see is our release branches. These are where every release is made, where every feature is made. And on the right side, we have the content. So right now, we have the content is totally decoupled from the game code. And the important bit is that package in the middle that we call content scripts. This is basically the only UPM package with assembly definition file where we allow code that lives in our content package to be in. So it is very important then if you integrate content in a number of old releases of old code that you do serialization well. You have to take a lot of care about what you do with your serialization. But the good thing is that now your changes are way more predictable. Like if you're doing addressables and you did some content updates, like you have no idea what's in there. Now, you even can like restrict the code what's in there. You can restrict the dependencies. You can say, okay, I can only references these kind of assembly definition files in my content, and the others will just fail on compile time. And now that we are going like from that release branch approach to more trunk-based development approach, what we did is like we had on the upper screenshot, you see what was StumbleGuys before. Like we had a lot of huge bundles that, like Attilio said, there is a lot of things in there. I have no idea what is in those bundles. Plus, they are marked even with release numbers. So if anybody can tell me what's in that LiveOps R066, I'll give you $100. I have no idea. So when you optimize, like when you analyze your content, your use cases, you have to think about context. So context is how do you use your things? How you download it? Where it is used? Where it's loaded? So on the left, on the upper screenshot, you basically see what we have now. Like, I think everybody in this room can tell me what's in the Battle Pass theme, what's in the events theme. So it would be like, if I tell you, yeah, they're like the images for that event. Yeah, it's, I don't know, you can read it and it's there. This is super good, and you will end up with smaller bundles, but you will end up with a lot of smaller bundles, which then again, so now we know how to manage our content, but now we're managing a lot of little files, a lot of little groups that you have to go into your addressable view window, your project grows, and you outgrow that window. One example is that if you open that addressable group window in StumbleGuys, it takes about 39 seconds to open. I don't know, I think nobody wants to open that window. It's horrible. Like they have this huge list, you can't filter it. It's like you can't search it. If you search it, it goes there. It's not, oh, okay. Ditch it. So what we said is like, why don't we use the project window? Like it scales already with our project. And say hello to what we call the addressable group definition files. I normally say like addressable definition files, but it's too long, but okay. So what is that file? Basically, as we're developers, we like to code. We think, why assembly definition files that work for code? Couldn't we have something that works for content too? So it's basically, we put a scriptable object, and that scriptable object within a folder governs how that folder is converted automatically into an addressable group. So it's basically the same. In an assembly definition file, you have your C# script that gets into DLL. We have our assets that will generate a group, and that's it. It gives you the benefit that you don't have to take care about creating your groups anymore. You don't have to take care about opening that horrible window with 2,000 groups, whatever. Plus, you can take care of your hard stuff like naming. I hate naming. So I don't name addressable groups anymore, and that's super good. Plus, you have an additional layer on top of your setup that you can do automation, you can like do whatever you want. Plus, you avoid human errors. Like if you use addressables and you know how many little checkboxes and sliders and to get the sliders right, I have no idea about those sliders. Like it's one setup, once tested, it's there. So there are no sliders. There's nothing. You just expose what you need for your content people to use. So I wanted to give you some examples of the things that we do and might be useful. For example, you can surface errors. Like the first errors, I think you can see that. I guess, right, okay. So like, you haven't configured a group, like the template is not there, or it's not available in that version. There is, for example, in the, what we added is we have a version constraint for each group. So with that in mind, stability that we integrate in content into different releases, we have to keep in mind that there might be breaking changes. And if there is a breaking change for all the release, we have to remove that group. So we have a flexible, that's actually text, it's like math. So you have your open brackets, your close brackets, you have your two regions and stuff. So you can decide, it's also a list. So you can decide what is in which release, when, and how. And of course, that gets into unit testing. So even then you can unit test all your groups, all your little thingies. You can create validators, filters, whatever. Such a system is just on top of addressables that helps a lot. And again, we're talking with scale, and scale always hurts you. So now it's all fine, but now you have about 2,000 addressable definition files, which again, you have to, when someone says to you, yeah, there's a bug, you have to check test in like that checkbox in that 2,000 files. So that's like a nice job. So if you do such a system, please, I encourage you to create a template system with it. So what we do is we have a regex file. You can have your templates that you want, and the only thing that you do is in batch mode, like in a batch, you just get all the definition files, you change them, and that's it. So please, if you go that route, don't make your life harder than it should be. And this is basically how it's used. So it is based on two post processes. The first post processor takes care of looking into the folder structure that addressable definition file is covering and updates the addressable definition file and saves it out. When that file is saved out, as the second post processor kicks in and picks that file and tries to update, synchronize the addressable group. If the addressable group is not there, it creates it. If it's there, it updates it. That's very important. So by any means, please do update your addressable groups. Don't think it's easier to just, I remove it and I edit. Then you will change the UID of the addressable groups, and that bundle will be rebuilt in full. So don't do it. Okay, now we have our content. We have our 200 artists creating new skins. We have to get that to the players somehow. So on Stumble Guys, what we do, the first thing that we do is we do a player build with the content itself. The player build will be our checkpoint, our initial checkpoint, what we call a content stream. And to mark that player build, to not lose it, to get where it should be, we use the comment hash. Where do we use the comment hash? There is an override, I don't know if you know that, it's called the player version. The player version is addressables, is a suffix that addressables adds as a timestamp by default into the catalog. Like if you build addressables, you know that catalog underscore, and you get like a huge timestamp there. You can change that to your needs. So we changed that to be the comment hash of our repository. So this way, when we have to like recover the same state of the repo, we know it because it's the comment hash. We just have to save the comment hash somewhere. So we get predictability on our build system, predictability on generating the URLs on the client side. So there's no problem. And it gives you traceability back to their CDN. Like it's always good to know where that build came from for logs, for stuff, and for nice CDN, CI/CD debugging. So what's the content pipeline? So now we're building. We have those two build pipelines. What we do, we created a scriptable object-based system because I know if you do building and build system get complex basically. If you do it all in code, it will be messy. So we have two paths, which is the normal the player build, which basically is as simple as I do my content, I do my Unity player build, I upload the build state to the CDN, and I upload the, sorry, not the CDN, the build itself, the asset bundles plus the catalog files, that hash and the JSON file, and we upload the build state to our S3. That S3 is basically the storage backend for our build system. On the other hand, if we're doing a content build, the first thing that we have to do, we have to recover the previous build. Like if you do an update, you need that state. So we recover the previous build, and we have two paths. I will go into that with two paths later, but basically you have a full update or the incremental update. And then it's the same. We just get it up to the CDN and our S3. So this is basically how it looks like. I won't go into every build step, just those three that are there that I think are important. But setting up a build system like this, the good thing is that you can just drag and drop, test, and everything is scriptable objects, and nobody has to just create it where you want. You put it in, and it works. So let's go into the processing build step. That build step is run on every group before we do any build. And it's basically our cornerstone, like our tempo for the content updates. We use the prevent updates flag. Does anybody know what that flag does? Yes, hands up. But you know it, or you think you know it because of the naming, because that naming is bonkers. You know, it's like, we use that flag to true to do an update. So we're preventing the update, doing an update, like totally logic. I'm bad at naming, so I have no idea if there's a better name for that. It's impossible to know. So that flag, what it does, on a group, and you do an update, Addressables will collect the changes of that group, and it won't let you update the initial group. But it'll pick up all the entries that changed and giving you an option to move those entries into a new group that is called the content update group. Then you do the build. Then on your client, on the application, the user will just pop out the game, and they will have a new inventory with that new group. And the idea behind that is that now every addressable request that was meant to be going into the old group for an item that changed is redirected to the new one. So you effectively have delta updates with this. So what is the full update? What's the normal update? So the full update for us is basically we try to build as much as possible. Like we have a live game, it makes money, it's a lot of players, we need to have a safe harbor path. So that full update basically tries to build everything from scratch if it can. Obviously, the local groups, they can't because the players have them already in the APK, in the EBA, or in the X files. But you can, we just rebuild all remote groups, and of course, new groups, player doesn't have them, you have to rebuild them from scratch. And the update path tries the opposite. It tries to avoid rebuilding as much as possible. What we do is we use the build state from the previous build, being an update, being an initial build, doesn't matter. And we try for local groups and remote groups just to check the changes and put them into the new update groups. Again, new groups are new groups. The player doesn't have them, so you have to build them. And now we go into the content update itself. This is the most fun part of this talk. Just a question. Does anybody had issues with hashes, asset hashes, and one hand, oh, a couple of hands. Okay, like all, you can just raise it. So basically, the Unity uses what is called the addressable content state bin file. If you don't know what's in there, one of the key elements is that there is a key, there's a dictionary that that marks basically your assets, UIDs to the asset hashes in your local asset database. So this means that those hashes are non-deterministic, or they could be. It's like you should build it always on the same build machine. You should always on the same operating system. Sorry, we spin up Docker containers that have different usernames, so then it's just broken. So what we did is we changed addressables a bit. It's an open package. You can do that, and we use Git. How do we use Git? So as we split our content from our game, now we can have to commit hashes from the previous, from the previous build and the current state. And we can collect all the changes that are in there. We know those are the changes. Those are the files that changed. So we feed that back into addressables. Addressables gives us the entries that the addressable things are modified based on that input that we gave addressables. And then we just create the content update groups again. So it's basically, hashes don't work, don't use them. It's plain and simple, but yeah, it works. So with this, you actually have full control over what changed. Because now you can decide, okay, I don't want any change in my base game. I don't want any change, even if there is a change in a group that I don't want to deliver to the players because, I don't know, there is a rounding floor point error always in that asset. Every time I open Unity, every time it gets dirty. This, I don't want to get changed, never, ever. You can do that now. And then we go to our build artifacts. The build artifacts are those build states that I said that you have to save up, then you recover. Basically, the initial player build is also a bit tricky. Creates two build artifacts, two build states. One, to save out that initial player state that we said, so that if everything, we break everything, we always have that safe player state to recover from. And it saves the initial update. And then every update or every content build that we do saves another one, generates another one, which is the update state. So the idea behind that is like a double buffer. So you do an update, you get your initial one, you produce the next one. So until you're done, until you're deploying it, you actually can iterate on your update. So you don't have to push that update with just one texture right away. You can prepare your team, you can do a milestone that in 2 weeks we have to have the update done, and you start working on the update, and when it's done, you hit deploy. What we save basically in that artifact, in that build state, is the previous build state file, the addressable state bin file for that build. We save the group information. For example, to play with the prevent updates flag, we have to save out what will be a new group for the next build, so they can set up the flag correctly. Everything that you need to play around with that flag. The player version and basically every additional information that you have. We add the total amount of update. That update is the amount of bundles, the size, the download size, the whatever, plus the commit hash for our content repo. So just save what everything you need is useful. for you. And now we go to the last part, which is the deploy. So deploying is pretty simple in Addressables. You already did that, basically. Like we update, we upload all our bundles, and we upload all our catalog files. But we don't upload the catalog files as is. We upload them with a postfix, with a pre-postfix. This is, so basically, we can decide when the player will get that update. Like, the remote load path doesn't have that prefix, that postfix, so they will still address the old one. So we can go through testing, we can go through QA, we can go through our environments and decide when to hit that deploy button. And the deploy button is as simple as just rename the file on your CDN. Important, if you rename on the CDN something and the URL hasn't changed, you have to invalidate that. Like if you're using CloudFront, you have to do an invalidation on CloudFront. Also, avoid, at any cost, overwriting existing bundles. Like even if the bundle is the same, just don't do it, because then your CDN will try to refresh it. Like even if it's the same bundle, it will refresh it, and that is money. So don't do it. There's no need for it. And this is an example of, with the transform internal ID custom, that function that we do internally, is basically to change the URL of the catalog that we're addressing. It's super simple. I don't know. It's like Attilio said, it's super powerful to do whatever you like. So we have a feature flag to point to a new catalog, and then the catalog gets downloaded. Also, don't be afraid to put anything in there. Like if the catalog URL is pointing to something that's non-existing, internally you will fall back to the previous version that you had cached. So it won't break anything, which is good too. And this is basically how we deliver stuff.